All right, welcome to chapter 4, part 2. We are going to talk about complex substituent naming and some bicyclic compound naming in this video. So I just want to start off here with a summary slide. We know how to identify the parent, identify and name most substituents, simple and halo substituents anyway. Number the chain and assign that locant to each substituent, and then arrange it, right? List the numbered substituents before the parent name, but put them in alphabetical order. Now, I skipped over in the last video what to do with complex substituent naming. And so I want to talk about this here. So complex. So it's not just a simple straight chain or a simple ring, right? That you can just say 1 carbon, methane becomes methyl. 3 carbon ring, cyclopropane becomes cyclopropyl. What if you have a chain that has branching on it? So for naming complex substituents, there's 2 things we're going to go over. We're going to go over the IUPAC way to name it, so the rules that will give you the structure, or the rules to the name that will give you the structure, and then also 4 common names that you need to memorize. So the first things first is you are going to number the substituent. So again, you're looking for that longest chain within the substituent, but when you number it, number 1 is, it doesn't matter where the branches are. Number 1 is always the carbon attached to the parent. So you notice in their example here, we start numbering here at 1, not because there's a methyl group on carbon 2, but because number 1 is the carbon that is attached to that parent. All right, so you number it. So in this case, you have 4 carbons in a row, so this is butyl. But on that butyl chain, there is a single carbon, right? So that becomes a 2-methyl butyl. But how can we have 2 different numbering schemes? Because this is obviously going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, this would be undecane. You don't have to know undecane, but that's what we're dealing with here. And so either way, we number 1, 2, 3, 4, 5, 6, 8. If we number it from the right or the left, this whole thing is on carbon 6. Well, it would be confusing if we don't do something different for that numbering scheme in the kind of the secondary structure in the substituent there. And so we bring in parentheses. The parentheses tell us, okay, this next number that's coming, that is from the substituent. That is not from the parent, right? So the parentheses are critical here. So in this case, the thing that we're naming would be 6. Okay, so 6 is outside the parentheses. That's telling me that's carbon 6 on the parent. 6 on the parent, then inside the parentheses, we have 2-methyl-butyl, right? Not methyl-butane, methyl-butyl, because it's still a substituent. It's just a substituent on a substituent. Close your parentheses, and now you can put your parent, undecane. Right, so you're going to use parentheses and you're going to use a secondary numbering scheme. So you can name any sort of branch chain substituent, any sort of complex branched substituent. You can name using this method. There are common names for specific complex substituents, and there are 4, I'm going to make you memorize 4 of them that are so common. You see them all the time, and it's really useful that you just know them. So the first one that you need to know, so your common name complex substituents is going to be isopropyl. So let's say you have your parent, and then you have this little branch chain here coming off of it. This is going to be carbon 1 And then whether I number up or down doesn't really matter. So we'll just say 1, 2. So you could name this in parentheses, right? 1-methyl ethyl. Right? Because 1, 2, that's 2 carbons. It's an ethyl group. And then this carbon here is on carbon 1 of the ethyl group. So it's a 1-methyl ethyl. But more commonly, it's known as isopropyl, right? So normal propyl would be 3 carbons in a row. Isopropyl is this, little chicken leg sticking out here, this little foot, right? And so it's a branch. And you need to know this, right? So possible example might be easiest, just throw it on a ring here. This would be isopropyl cyclohexane, or equally acceptable 1-methyl ethyl, and the 1 is in the parentheses, cyclohexane. Either one is accepted by me if you are naming something, but you need to know both in case you come across, say, a multiple choice question or a bottle of isopropyl alcohol, right? This is a very common name, and so it is important that you know it. The other 3 are based on butane. So a butyl group is 1, 2, 3, 4 carbons in a row. But if you have other 4 carbon substituents that are not in a row, not straight chain, they are going to have complex naming. So they're there, but you'll find if you ever come to office hours, I like to write while I'm talking. So for our first one, and in this case, let's just do a longer chain here. Right, so there's our parent, 1, 2, 3, 4, 5, 6, 7. So we have a heptane. You could number this, you could do the IUPAC way. And I'm going to do 1', 2', 3', just to show it's a separate numbering system. This will be on carbon 4 of the parent. You have a 1-methyl propyl group, or sec-butyl, the sec-butyl heptane. All right, so sec-butyl is one that you need to know. Let's go back to our ring. We'll do cyclopentane. Another possibility, I just drew sec-butyl again, excuse me, would be the branching 1 carbon down. In this case, 1, 2, 3. Excuse me. On carbon 2, we have a methyl group. So in the parentheses, 2-methyl propyl cyclopentane. Now, I don't have to put a number on the outside because it's cyclic. So it could be 1 parentheses 2-methyl propyl cyclopentane, but it's not necessary. And then finally, let's go back to maybe our straight chain. And here we have what is known as the tert-butyl group. 1, 2. So this one would be in parentheses 1, 1 dimethyl. Still going to use my rules for multiple methyl groups here. Right? We have 1, 2. Dimethyl ethyl. And then what did I draw? 1, 2, 3, 4, 5, 6, 7, 8. Octane. Now, it's not a ring, so I do have to state that that group is on the 3rd carbon. Or I could call this 3 tert butyl octane. I realized something I left out. Right, the common name tert-butyl. Obviously, I left that out on this one. When you have the methyl group on the 2nd carbon, that is your isobutyl group. Isobutyl cyclopentane is another possible way to name it. So you need to memorize isopropyl, sec-butyl, isobutyl, and tert-butyl. Now, here is something crazy. When you are putting down every substituent at the end and you are alphabetizing, it's important that you know what counts and what doesn't count for alphabetizing. The Greek prefixes do not count. Do not count. So, for instance, if we had something like this. 1, 2, 3, 4, 5, 6. We have an ethyl and we have 2 methyls. This is 2,2-dimethyl. This is 3-ethyl. You do not count the Greek prefix. You are comparing M to E. So this will still be 3-ethyl, 2,2-dimethyl, hexane. Okay? Another thing to point out, especially with these common names, it's a little bit tricky. Isopropyl and isobutyl, the I counts. Use the I. However, for sec-butyl and for tert-butyl, you use the B. And all I can say that helps me remember, sec stands for secondary. It has to do with the carbon that is attached to the parent, and tert stands for tertiary. So they still are referencing a number, kind of like di, tri, tetra, referencing something numerical. And if it's referencing something numerical, you do not count it. Iso is just sort of like, this is part of the name, and so you do count it. And so those are things to keep in mind when you are putting your name together. So now I want to come out here to this very bad example. And it's important that you listen to your lectures and you go through them with me, because not every slide is perfect. And this is a good example of one. So we have a cyclohexane parent. We have a tert-butyl group, an ethyl group, and 2 methyls. And this is numbered incorrectly. Numbered wrong. Ugh, shame. Okay, why is it numbered incorrectly? Because if you start with this one, 1, 2, 4, 4 is what you wind up with for your numbering. However, if you number starting here, 1, 2, 3, 4, you get 1, 1, 3, 4. And the first difference is the one that matters. And 1 is lower than 2. So the real name of this should be, we still are going to write down the tert-butyl first, because B comes before E, comes before M. But it's going to be 4 tert-butyl, 3 ethyl, 1, 1, because both methyl groups need to have a number, dimethyl cyclohexane. All right, so you have to keep all of those details in mind when you are practicing. I have a whole nomenclature practice sheet up for you. Your homework has some nomenclature practice, and I will also provide a link on eCampus to a Nomenclature 101 site that I recommend that you use for practice. You should definitely do more practice than you are required to do before you go into the exam. You really want to nail down these rules. And so for the final thing I want to talk about in this video is how to name bicyclic compounds. So bicyclic compounds are fused rings, and that is different from something like this. This is not fused. These are two separate rings and carbons within the rings are bonded. This would be cyclopentyl, cyclohexane. Fused rings share carbons. Shared carbons, right? And so there's two types. There's a bicyclo, and bicyclo compounds are fused rings that share two carbons. And then one that Klein doesn't mention is Spiro. We're going to go over it. You will be responsible for knowing them. Spiro compounds are fused ring systems that share one carbon. And they're pretty easy to name, honestly. So we're going to start with bicyclo. The bicyclo compounds follow the same format for each one. It's bicyclo, brackets, not parentheses, brackets. And then there will be a number, period, number, period, number, period. Or, well, close brackets. So it's bicyclo, 3 numbers, and then an alkane parent. And the way it works is you find with the bicyclo, so for instance, we'll use this one. We'll look at both representations. So this is sort of looking at this fused ring from the top, kind of an aerial view. This shows it from the side, kind of shows the 3-dimensional structure a little bit more. But in both cases, you have a 1, 2, 3, 4, 5, 6 carbon ring. And then across it, you have 1 carbon. And then you kind of share 2 carbons within both rings. So either way, the carbon that is shared by both rings, the ones that I am making bold here, these are called the bridgehead carbons. And the bridgeheads are very important because that is how you are going to get those numbers. So there are going to be 3 paths from one bridgehead to the other. For instance, we can go down left, down right, or straight down. And you're going to count, not the bridgehead. You're going to count how many carbons are between the bridgeheads on the path. So we have 1, and maybe I won't highlight them that way. Hold on. We have 1 here. Going on this path, we have 2, and this path, we have 2. And you are going to write the numbers in increasing order. So it's going to be 1, 2, 2, close the brackets. And then the alkane name, you are going to count all of the carbons. So for this one, we are going to go, okay, 1, 2, 3, 4, 5, 6, 7. 7 carbons total. This is a heptane. All right, so bicyclo, 1, 2, 2, heptane. Now, something to keep in mind. Not all paths have a carbon on them. So look at something like this. This is a fused ring system. Very clearly 2 rings that share 2 carbons. So those are my bridgeheads. So this becomes bicyclo. There are 0 carbons there. So 0, 4, 4. And I don't know if it's increasing or decreasing now that I'm looking at it. I'll take either one. 0, 4, 4. But then how many carbons altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So bicyclo 0, 4, 4, decane. Right? So pretty simple. If you practice through a few examples, you will get the hang of this one. We're not going to talk about naming substituents on bicyclic rings. Oh, I did it wrong. Look over here. It's decreasing. So we want to go for decreasing. Let's just fix that since we're recording, shall we? All right. We'll get rid of the numbers there. This one would be 2, 2, 1. And the one down here would be 4, 4, 0. So decreasing order. Okay, now lastly, for Spiro compounds, it's going to go Spiro, bracket number, period number, bracket. So there's only 2 numbers, and then alkane. So what might a Spiro compound look like? Straw, something like this. We have 2 rings here sharing 1 carbon, 1 bridgehead. You're going to follow the same rules. You're going to count the carbons that connect the bridgehead back to itself. So on one side we have 1, 2, 3, 4, 5. And on the other side we have 1, 2. So this one becomes Spiro 5, 2. Close my bracket. We have 6, 7, 8. There are 8 carbons, so this is an octane. In the nomenclature practice I've put up for you, there are some bicyclo and Spiro compounds for your practicing experience. When we come back to part 3, probably next week, we will start talking about isomers and conformers. All right, see you in the